All right, so this is chapter 9, and we're going to start off with circles. Chapter 9 is all about conics, and conic section, the intersection of a plane with a double, it's called a double naped cone. And basically that means that we just have two cones that are sort of pointing at each other, for lack of better words. And we're only going to be worried about the basic conics. We're not going to worry about the degenerate conics. But each of these shapes, and you're all familiar with the shapes, but the shapes come from taking a plane, that's the plane, and slicing through either part of or one of or both of the double naped cones. And so if we take a plane and we cut it through a cone and we do it so it's sort of parallel to the base, so this plane is parallel to the base. If we do that, then we get a circle because, and we know what a circle is. It's the set of all points that are equidistant from a fixed point in the center, which we'll get to in a minute. So, but then if we take that plane and we just change the angle of it, so it's no longer parallel to the base, but we have a slight angle, then we're going to create an ellipse. So circle, it's all equidistant, ellipse, we're going to have something like that. And if we take a plane, if we just cut through one of the cones in such a way that we actually come through the base here, then that's what creates our parabola. All right, and then if we take that plane and we actually cut through both of the cones in such a way that it's kind of perpendicular, so this plane here is sort of perpendicular to the base. But if we do that, and it's directly perpendicular, then that's when we have our hyperbola, where these two shapes are exactly the same. And we're going to learn about like the distance between these two shapes and everything else like that, and how the shapes get their shape. So those are the different conics, and so we have four conics that we're going to deal with: the circle, the ellipse, the parabola, and the hyperbola. So the general form, and again, this is the general form, and we'll be talking about general forms and standard forms. So right now we're about the general form of a conic. So all four of these shapes, actually seven of these shapes, can be written with the same equation. It's just what coefficients are. So the general form of a conic, the general equation is ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Now, depending on what the coefficients are, if A, B, C, D, E, or F, if they're 0, then that would go away. And in fact, in most cases, B equals 0. So we would not have, an XY, right? At least definitely not in the case of these four conics. Okay, so if B were 0, then X and Y wouldn't be there anymore. If if A were 0, then we would just have, if A were 0 and B were 0, then our equation would just have y squared. And that's where we have our parabolas, or x squared. So all of these can be written in this general form. But we also, each of these shapes have a standard form, and that's what we'll be looking at. So each shape, there's a standard form for a circle, standard form for ellipse, standard form for parabola, standard form for hyperbola. But again, the general form of a conic, that includes all conics. We already talked about this. A circle is a set of all points equidistant to a fixed point, aka also known as the center. Okay? And then the distance, so here is our center, and then we have a fixed point, x and y. We have an infinite number of fixed points. We have x sub 2, y sub 2. All right, so all of these points, x sub 3, y sub 3, all of these points are all equidistant from C. So this distance, they're all the same. And we know that the distance between the center to a point on the circle, that is our radius. So the radius is the distance from the center to a point on the circle. Okay, and the standard form. So the standard form equation of a circle is based on the it's based on the distance formula. So again, we have our center here. We have this x and y, and the distance formula we know is d squared equals x sub 2 minus x sub 1 if we're taking the distance between any 2 points. So we have this point, and this is x sub 2, y sub 2, and this is x sub 1, y sub 1. So if we want to find the distance between these 2 points, this distance here, distance squared equals x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And to find the distance, then we just take the square root. Okay, so for the equation of the standard form equation of a circle, okay, we're going to use that equation, but we're using it to find, oops, no, that's all right. We're using it to find our radius. So radius squared equals, and in this case, we're not going to use x sub 2. The standard x and y value for the center is denoted by h and k. Okay, the h is the x value, the k is a y value. So this would be x minus h squared plus y minus k squared. And that is we typically write it like this. Okay, so that is our standard form of equation of a circle. So if it asks, hey, write the standard form of equation of a circle, it should be in this, it should look like this. All right, so let's take a look at a couple sample problems. So this problem gives us a point on the circle. So we have some circle here, and this is a point on it. Point should probably be over here. 1, -2. Well, no, I guess if this is -3, so it would be over here. Anyway, 1, -2. And the center of the circle is this -3, -5. Okay, so it gives us the center and gives us a point on the line. What it doesn't give us is it doesn't tell us what the radius is. So we use our standard equation, which is x minus h squared plus y minus k squared equals r squared. And we plug in those values. So this is our x and our y, and this is our h and our k. So I'm going to go 1 minus -3 squared, right? 1, -3, 1, -3. And I'm going to go plus -2 minus -5 squared. And again, that is -2, -2, -5, -5, right? So I do my math. Oh, this equals r squared. So 1 minus -3 is 4 squared. -2 plus 5 is 3 squared equals r squared. 16 plus 9 equals r squared. So r squared equals 25. Now the radius then of this circle is 5, but we don't care about the radius. It's not asking for the radius. It wants us to write the standard form equation. And for the standard form of the equation, we need the radius squared, and we need to know what the center of the circle is. We need to know what h and k are, right? Because that's all these components. We need to go h, we need to know k, and we need to know r squared. So now I can write this as x plus 3, right? Because it's x minus a -3. So it's x plus 3 squared plus y plus 5, because again it's y minus a -5 So that gives me y plus 5 squared equals 25, or r squared. Okay, so our center is -3, -5, and our radius equals 5. Right, not 25, that's the radius squared. Okay, before we go on to that, let's do this. Let's rewrite, this is a standard form, right? Now let's rewrite that though as, in blue, let's write it as the general form of a conic, specifically of a circle. So to do that, we take our equation and we expand it. I'm going to do it over here. So I'm going to go x plus 3 squared plus y plus 5 squared equals 25. So this is going to be x squared plus 6x plus 9 plus y squared plus 10y plus 25 equals 25. Now I can simplify it and kind of put everything together. So I've got x squared plus y squared plus 6x plus 10y, and then I'm subtracting 25 from both sides, so that basically cancels those out. It leaves me with plus 9 equals 0. So this is the general form. Now, the question I asked in class is, if you were given this and you're asked, well, what kind of a conic is this? How would we know that this is a circle, that this is not a parabola, it's not a hyperbola, it's not an ellipse? How do we know it's a circle? And the answer to that is based on the coefficients. So we know that in this case, a equals 1, b equals 0, because it's not even on there. There's no x and y. No x and y. C equals 1, D equals 6, E equals 10, and F equals 9. Well, the fact that A and C both have the same coefficient, in this case it's 1, then we know it's a circle. So when A equals C, the coefficient A equals C, then it is a circle. And when we get to the other conics, you'll see that that's not the case. It's only the case for a circle. Okay. Let's go ahead and run through this. So we have to, so it says find the standard form of the equation of a circle. So this is in the general form, and then it wants to find the center, the radius, x and y intercepts. So first what we're going to do is we're going to get all the like terms together. X squared minus 2x plus y squared plus 4y equals 4. So like terms together, and then the one number that doesn't have a variable, we move to the other side, okay? And number without variable, move to the other side of the equal sign, okay? Now, the next part is to complete the square. Next thing is CTS, complete the square. Hopefully you all remember how to do that. We go x squared minus 2x plus some value plus y squared plus 4y plus some value equals 4 plus whatever that value is plus whatever that value is. So completing the square is b divided by 2 squared. So I come down here and I go negative 2 divided by 2 squared. Negative 2 divided by 2 is negative 1. Negative 1 squared is 1. So I put 1 here. I put 1 over here. Come down here. 4 divided by 2 is 2. 2 squared is 4. So I put 4 here and I put 4 here. Okay, so now I have x squared minus 2x plus 1 plus y squared plus 4y plus 4. All of that equals 9. Remembering our factoring, we're going to do over here, x squared minus 2x plus 1. That is x minus 1 times x minus 1, or x minus 1 squared. So that's what's going down here. X minus 1 squared plus, same thing, y squared plus 4y plus 4 is y plus 2 times y plus 2, or y plus 2 squared. So y plus 2 squared equals 9. Okay, and that is the standard form of a circle. So that's this first part here, standard form of a circle. Next, it wants to know the center. Well, the centers are h and our k. So center, hk. So that's going to be 1 and negative 2. Don't make the mistake, don't say negative 1 and 2. It's 1 and negative 2 because it's x minus h and y minus k. All right? Here's my center. And then it wants the radius. And we know that this value here is r squared. So if r squared equals 9, then our radius equals 3. All right? And then the last part here, it wants to know our x and y intercepts. So for x-intercept, y equals 0. So I'm going to use this equation here. It's better to use this equation. Math is easier. So go x minus 1 squared plus 0 plus 2 squared equals 9. X minus 1 squared plus 4 equals 9. X minus 1 squared equals 5. So I'm going to take the square root of both sides. So I have x minus 1 equals positive negative square root of 5. So my x-intercepts are going to be, remember, x-intercepts are a point. So it's going to be, oh, I'm sorry, didn't finish this. X equals 1 plus or minus square root of 5. So my x-intercepts are going to be 1 minus square root of 5, 0, x and y value. Okay? And then my other intercepts are going to be 1 plus the square root of 5, 0, again, x and y value. So those are my x-intercepts. Y-intercepts, we do the same thing. Y-intercepts, we are going to take that same equation. We're going to set x equal to 0. So 0 minus 1 squared plus y plus 2 squared equals 9. So this is 1 plus y plus 2 squared equals 9. Y plus 2 squared equals 8. Y plus 2 equals the square root of 8 plus or minus. So y equals negative 2 plus or minus the square root of 8. So my y-intercepts are going to be 0, negative 2 minus square root of 8, and 0, negative 2 plus square root of 8. Okay, that would be my answer. Or, if you want to simplify it, negative 2 minus 2 root 2. If you wanted to simplify it and be a real top-notch mathematician, that would be, this is the Calc AB answer, this is a regular Calc answer. Okay, now we have this bonus question. Same idea, asking for all the same stuff. Oh, I didn't graph it. Over here, let me graph it really quick. Graphing it's real simple. Take your center, so 1, negative 2, and we notice our radius is 3, so I go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so that's my radius of 3, and then I just tried it nice and neatly. That wasn't very neat. I try to draw my circle through those points. Okay, and those are there's our x-intercepts, and there's our y-intercepts. And we don't need them to draw it. We're asked to find them. Okay, very quickly, because I got to go. Same idea here. Get everything together. Now you could, if you wanted to, you could bring the 17 over and you could divide everything by 9. But we're going to do it a little bit cleaner. I'm just going to go 9x squared plus 54x plus 9y squared minus 36y equals negative 17. I'm going to factor out the 9 plus 6x plus some value. We have 9y squared minus 4y plus some value equals negative 17. Now, here's the key here. Again, we complete the square. 6 divided by 2 squared, that's 3. 3 squared is 9. Negative 4 divided by 2 squared, that's negative 2 squared, that's 4. Do not do this. Do not then go and add plus 9 and plus 4. Okay, don't do that. You have to take into account the fact that you have this 9. So what you really add on here is you're going to go plus 81, because 9 times 9 is 81, plus 36. So now I have, now I have 9, I'm going to go ahead and do this, x plus 3 squared plus 9, x minus 2, or y minus 2 squared equals 100. Now I can divide everything by 9, 9, and I have x plus 3 squared plus y minus 2 squared equals 100 over 9. That is the standard form. The center is going to be negative 3 and 2, and the radius is going to be 10 over 3. Okay, you can find the x-intercept and the y-intercepts, okay, just using this equation here and plugging in, x equals 0 for the y-intercept and y equals